66% of developers say their number one frustration with AI coding tools is code that's almost right, but not quite. And here's the thing that nobody's saying out loud. Almost right is more expensive than completely wrong. Completely wrong gets caught, tests fail, build breaks, someone says this doesn't work, and you throw it away. Almost right passes code review, almost right ships to production, almost right sits in your code base for 6 months before anyone realizes it's wrong. And by then, the cost to fix has compounded into something nobody budgeted for. We manage multiple client code bases right now. Every single one of them is generating this debt. I've been shipping production systems for 15 years. This is a new pattern and it's everywhere. Today I'm going to show you the 5 specific patterns of AI generated debt, why they're harder to catch than traditional debt, and the 3-question code review framework we use on every AI generated PR. We've got 5 patterns, 1 principle, 1 framework. Let's go. Let me tell you about a PR I reviewed 3 months ago. It was a client project, mid-sized startup. They've had great engineers and they adopted AI coding tools across the team. Cloud Code, Copilot, Cursor, the works. Their velocity was up, the PRs were flowing, and everybody was happy. I opened the pull request, it was clean code, tests were passing, TypeScript, well structured, everything looked great. And then I started reading the actual lines. ESLint disable next line, no explicit any. Then another one, ESLint disable next lines, no unused vars. Then another one, 11 ESLint disable comments in one file. And this wasn't an outlier. I searched the rest of the code base and there was over 200 ESLint disable comments across the project, most added in the last 3 months since the team started using AI tools. The AI hadn't fixed the TypeScript errors it was finding along the way, it had suppressed them. Every single one, the type system was screaming, this is wrong, and the AI solution was to put tape over the warning light and hold it hostage. And here's the brutal part, this PR had been approved by a human. A senior engineer looked at this, saw green checks, and hit merge. Not because they were lazy, but because the code looked right and it passed every automated gate, as it should. And the suppressions were hidden in plain sight. 2 weeks later, a production bug traced back to one of those suppressed type errors. The type system tried to warn us, we told it to shut up. That's the new technical debt. It doesn't look like debt, it looks like working code. And here's where it gets really interesting. I started cataloging the patterns, and there are 5, and once you see them, you can't unsee them. So pattern 1, broken flows that just nobody can debug. This is a true story. A client of mine had an OAuth PKCE authentication flow. For anyone who doesn't know, PKCE is how your app securely proves it's allowed to log in users. Multi-step handshake between your app and the auth provider. The AI generated the entire flow. It looked correct, variable names made sense, steps were in the right order, it even had comments explaining what each step did. Now there was one problem. The token exchange assumed local storage would always be available for the code verifier. It works in Chrome, works in Firefox, fails silently in Safari private browsing, which is how 20% of their users logged in, interestingly enough. The AI generated a common pattern that happens to break in one specific and very common scenario. And it took us 2 days to reproduce the bug and 2 hours to fix it. And yes, a thorough code review should have caught this, and that's the point. The AI generated code was good enough to pass the review that existed, which means your review process needs to be different for AI generated code. Now why 2 days? Because nobody on the team understood the PKC flow well enough to debug it. The AI wrote it, the AI explained it, nobody had to think about it until it broke. When AI writes code nobody understands, you haven't saved time, you've borrowed it with interest. And here's the uncomfortable truth. Some code is too critical for AI generation. You've got auth flows, payment processing, data migrations, and some code needs to be written by someone who understands it, not generated and reviewed, written. Then we got pattern 2. We have suppressed errors instead of fixed errors. This is that ESLint disable pattern from a story I just told you. The AI encountered a TypeScript error. The correct fix required understanding the type system, the data flow, why that type exists, but the fast fix that AI went was to suppress the warning. It thought, problem gone, warning gone. However, the error was still there, hidden behind a comment. And I've seen files with 15, 20 suppressed comments. Each one is a lie, and each one says this is fine when the type system is saying this is wrong, and an AI added it, not a human. Now, these compound, and the next AI-generated code references the broken types, suppresses the new errors too, layer on layer, until the type system is meaningless. Your type system is your immune system, and AI is teaching your code base to suppress its immune system. Then you've got pattern 3. Phantom code. This is where you have duplicate and dead exports. Your code base has a utility function. Format dates, used in 47 places, handles edge cases, it's tested, you know it works. However, sometimes when you have these kind of functions, AI may not know it exists. So when the developer asks AI to build a new feature that needs date formatting, the AI writes a new date formatting function, different name, slightly different implementation, and same purpose. But now you have 2. And then the next AI system review might add a 3rd, and then you might have 5, and it might grow. And this is also the same with type definitions. Your code base has a user type. The AI creates user data, then user info, then user response. 4 different types, all doing the same thing. And then it generates exports nobody calls, functions nobody references, constants nobody imports. Why? Because AI generates complete modules based on training data, not based on your code base. So if a new engineer joins the team, they see these exports and they're going to think they're used somewhere. They're afraid to remove them, they build around them, and now the dead code is alive and entangled. Your code base is growing horizontally, not because you're adding features, but because you've added redundancy. I've rebuilt many projects like this. And you know, when the founder called me, when the next feature costs 3 times what it should, when the simple change takes 2 weeks instead of 2 days, that's the compounded interest on code nobody needed in the first place. And unused code isn't harmless, it's confusing, and confusion is the root of all technical debt. Now here's the one that keeps me up at night, pattern 4. Code that works but doesn't follow your conventions. Every good team has conventions. How you name things, where state lives, how errors are handled, how files are structured. There's no right or wrong way of doing this, it's just opinions. However, AI doesn't know your conventions. It knows the internet's conventions. And the internet has a lot of opinions. And we had a client code base where half the files use Pascal case for components and half use camel case. Not a big deal, but then we also had 3 different error handling patterns. The AI had generated each file using whatever convention it felt like on the day and never adhered to what we already had that existed. And yes, newer tools like Cursor with code-based indexing are getting better at reading your context, but better isn't always reliable. And the question is still the same. Did the output actually follow your conventions or did it approximate them? One file that doesn't match is a quirk, however 10 files that don't match is a code base losing its identity. Now, these 5 patterns have the same root cause every time. The AI generates plausible code but not correct code, and plausible is the most dangerous word in software engineering. And here's a principle. This is a thing I want you to walk away with. The most expensive code your AI writes is the code that almost works. Completely wrong code is cheap, it fails fast, tests catch it, you throw it away, and it costs minutes. Almost right code is devastating. It passes tests, it ships, it sits in production, and the other code gets built on top of it. Dependencies will form, teams will adjust their mental model around it, and then it breaks, not today, not next week, but 3 months from now, under load, in an edge case, during a critical demo. And the cost isn't fixing one file, it's untangling 3 months of code built on a flawed foundation. Only 29% of developers trust AI-generated code. This was down from 40% the year before. Trust is dropping because the teams are learning this the hard way. Technical debt is financial debt. You're paying interest whether you see the invoice or not. And every feature that takes longer than it should, that's interest. Every bug that keeps appearing, that's interest. Every senior engineer who says, I don't understand this code base anymore, that's the interest. You're paying it whether you see the invoice or not. So what do you do about it? You don't stop using AI because that's not the answer. And here's a military term for you, force multiplier. Night vision goggles don't give you more soldiers, they make the soldiers you have more effective, but only if those soldiers know how to fight. Night vision goggles on someone who never had a weapon is useless and dangerous. AI is the same. It's a force multiplier, but you need the discipline to aim it. The answer is reviewing AI code the way you'd review code from a talented and brand new contractor who's never seen your code base before, because that's exactly what AI is. And we built a 3-question framework for every AI generated PR. 3 questions, it takes 30 seconds and catches most of the patterns I just showed you. So question 1, does it reuse? Before this code was written, did something already exist in our code base? Is there an existing utility, type, definition, or pattern that does the same thing? If yes, delete the new code and use the existing or modify the existing to facilitate the new pattern. This catches phantom code. 1 question, duplicates are dead, and exports are gone. And question 2, does it follow conventions? Does the naming match? Does the file structure match? Does the error handling match? Does this code look like it belongs in the code base, or does it look like it was dropped in from a different project? If it doesn't match, refactor it before it ships. This catches convention violations. And in question 3, can the developer explain it without reading the AI's comments? Not does it work, not can they read the AI's explanation back to me, but can the developer who submitted this PR walk through the logic line by line with the AI's comments deleted? And if they're reading documentation, that's not understanding. If they can't explain why PKC flow works the way it works without the AI's annotations, the code isn't ready. Send it back. Now this is going to catch broken workflows and suppress errors. If the developer can't explain it and they can't maintain it. Unmaintainable code is debt. Let me show you how fast this is. Last week, we had AI generated PR that landed. The question 1 was, does it reuse? I searched the code base and we already have a date formatter, so we delete the new one. Question 2, does it follow conventions? Error handling doesn't match our patterns, so we're going to refactor. And in question 3, can the dev walk me through it? Yes, he walked me through, explained everything, so we could ship it in 3 minutes and we're done. These are 3 questions and there's 4 patterns caught, and that was it. Now, here's what happens when you install this. Review times don't go up, they go down, because reviewers aren't reading every line trying to find something wrong. They're asking 3 specific questions with clear pass, fall, criteria. Each client team went from a 3-day review turnaround the same day, not because they reviewed less, because they knew exactly what to look for. New engineers onboard faster because the codebase has one way of doing things, not 5, and debugging goes from days to hours because the code is written by someone who understood it, not generated by a model that approximated it. And if you're the founder or executive hiring a dev team, this affects you too. You should ask your engineers to show me the last 5 PRs where AI generated the code, and can you explain each one? If they can't, you're accumulating debt that you can't see on any dashboard. The teams that shipped fastest at places like Shopify and Brex weren't the ones who wrote the most code, they were the ones whose code was most consistent, the most predictable, the most maintainable, every single time. AI makes disciplined teams unstoppable. AI makes undisciplined teams dangerous. Same tool, different foundations. So there's 4 patterns, 1 principle, 3 questions. Phantom code, suppressed errors, broken workflows, nobody can debug. Convention violations, the principle, the most expensive code is the code that almost works. The framework, does it reuse? Does it follow convention? Can the developer explain it without AI's help? If your team is using AI coding tools, and they are, pick 10 recent PRs, ask those 3 questions. What you find will tell you exactly where the debt is hiding. And if you want help diagnosing what's already accumulated in your code base, that's what a strategy session is for. We'll go through it, identify where the debt is hiding, and give you a plan to stop the compound interest. The link to get started is in the description, but even if you never talk to me and my team, take those 3 questions into your next code review. The AI tools aren't going away, the debt doesn't have to be inevitable. Your next PR review is what, a few hours away? These are just 3 questions, use them. That's all it takes. And if you want to understand the mindset that creates this debt in the first place, I made a whole video on vibe coding, and that video is about the mindset. This one is about the code base. Same problem, different layer. Watch it next.